Hello, hello, hello. Welcome back, ladies, gentlemen, and children of all ages, to another math video. Today we are going to be talking about complex numbers and things we can do with them. So, first thing we're going to talk about today is we're going to talk about graphing some complex numbers, okay? So first, if we wanted to graph the number 3, we would have a number line. A number line extends forever in both directions, generally is a straight line, extends forever in both directions, and we have things like 0 marked on here, and 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? And then we also have, so let's say, let's see, this is 2, 4, 6, 8, -1, -2, -3, -4, -5, -6, -7, -8, negative. Right? We could make this number line, and we could say, all right, the number 3, 2 is the number I was looking for, 2. Let's say that the number 3, actually I'm going to do this in a different color. Let's say that the number 3 shows up on this number line right here, right where that little tick mark is, okay? And then we have, say, the number -6, and we would plot that number on our number line, okay? So now we want to graph some complex numbers where we would have stuff like, -3 plus 0i, -3i, 4 plus 3i. What am I doing? Use different colors for all these points. You have the colors, use them. 3i, 4 plus 3i, and let's go ahead and let's do -2 plus 4i. Okay? So, in order to draw these, we have our real number axis, real numbers. But our real number axis takes care of all of the real parts of all of these complex numbers. Okay? Now we need something to take care of all of the imaginary parts. Now we need something to take care of all the imaginary parts. So the way we do that is we make another line. We make another line. And again, we have -1, -2, -3, -4, -5, -6. So we have something that looks like this, where we have a real axis and we also have an imaginary axis. All right, and so when you're going to graph these, don't overcomplicate things. If you're going to graph the real part at -3, and the imaginary part is at 0i, well, I don't have to go up or down the imaginary axis at all, so my -3 is going to live right here. My -3 plus 0i. Then if we used just positive 3i, well, we didn't have a real part, so now we're just going to go up to 3 on our imaginary axis. We also have 4 plus 3. So we're going to go start at the origin and go dot, 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 dot over to 4, plus 3i up to 3i. Then we have -2, so we're just going to start at the origin, go over to -2, and then go up to positive 4i. So this would be that point. All right? So on your own, I want you to graph a number for me. I want you to graph the number -3 minus 2i. Okay? Where would that guy live on our plane? Same idea. We're going to start at the origin, go over 3, down 2, until we get to negative, whoopsie daisies, I didn't go far enough. Over 3, down 2, to get to this point here. -3 minus 2i. Okay, so that's how you can graph some complex numbers. All right, graphing complex numbers. So now, hopefully that brings up the next idea that we're going to talk about. So recall that when we're talking about absolute value, we're talking about the distance a number is from 0. So let's say we took the absolute value of our number 2. So our number 2 shows up on our number line here, and it is 1, 2 units from 0. All right, so the absolute value of our number 2 is 2. Same goes for any positive integer. If we have a positive integer, let's say we have the absolute value of 20. Absolute value of 20. It's going to show up somewhere over here. That doesn't show up on my graph, but that's okay. If we measured the distance from that number all the way back, it's going to be 20 units from 0. Okay, it's our distance from 0. So now, if we take a look at a negative number, let's say we have negative 3. How many units is that from 0? Remember, it is 1, 2, 3. So our absolute value of negative 3 is just 3. If we take a look at a number like negative 1,812, that is 1,812 units from 0. Okay? So absolute value. That's how absolute value works with real numbers, with numbers that show up on our number line. But we're not dealing with real numbers in this particular unit, or in this particular section. We're dealing with imaginary numbers. So we would want to graph those like we would any other imaginary number on a plane with a real and imaginary axis. So let's take a look and find some absolute values of some complex numbers. So we want to plot our complex numbers on our graph. So negative 9 plus I is going to be this point right here, and it would help if you use the correct color pen when you do that. Negative 9 plus I is going to be this point right here. So when we were talking about real numbers, it was the distance from 0, that horizontal distance from 0. But with complex numbers, we don't have that nice straight line distance from 0, so we have to use our distance from the origin. How far is it from the origin to that point? Well, hopefully if you remember our good friend Pythagoras, he had a theorem that went something like this. A squared plus b squared equals c squared. All right? A is going to be the real part. B is going to be the imaginary part. And C is going to be the absolute value. So if we solve this guy for C, we get that C equals the square root of whatever A is squared plus whatever B is squared. So in this case, we take negative 9 and 1. So we take negative 9 squared plus 1 squared. Negative 9 times negative 9 and take the square root of that to get our absolute value. And we get that negative 9 squared is, negative 9 squared is 81, and 1 squared is 1. So we get that the absolute value of negative 9 plus I is equal to the square root of 82, which is our distance from our point negative 9 plus I to our origin. There's our distance from one to the other. So go ahead, do the same thing. You are tasked with finding the absolute value of the point 1 minus 2I. Take a few seconds, see what you come up with. Ready, set, go. All right, here's hoping you came up with the absolute value of 1 minus 2I being the square root of 5. So if we take and we plot our point, we get this point right here. This point that went 1 over and 2 down. Okay, 1 over 2 down for our real part and our imaginary part. Okay, so we have this point here. It's vertical distance went 2, its horizontal distance went 1. So we take the square root of 1 squared plus negative 2 squared. Our real part squared plus our imaginary part squared. Then we took the square root of both of those, which once we simplified it was 1 plus 4. Then, adding those two together, we get 5. The square root of 5 is the absolute value from 0 for the absolute value, the distance from the origin of our point 1 minus 2i. It's in square root of 5. All right, so next, let's take a look at a couple ideas. Hopefully that feels good, makes sense. Let's take a look at a couple more points that hopefully will be a little bit on the more straightforward side. Let's say we take a look at our point negative 4i. All right, this is our number that we're trying to find the absolute value of. We're trying to find the absolute value of negative 4i. Well, again, we're going to plot that point, negative 1, negative 2, negative 3, negative 4, which is going to be right here. We don't have any positive or negative distance, so here, if we try to do the same thing, we'd have 0 plus 4 squared. And we take the square root of that. Well, 0 squared is 0 plus 4 squared, which is 16. 0 plus 16 is 16, and our distance is 4 units. Okay? Our distance is 4 units from 0. We don't have any square roots or anything because we're right on this line. We don't have a triangle anymore. We just have a straight line. Same idea for a number like, let's say we had 7. Absolute value of 7, again, is going to fall right on this line. We count that distance. It's 7 units. Absolute value of 7 is still 7. Okay, same idea, same things work in all places, in all venues, everything. It's just we have to do a little bit more work to find our absolute values when we have an actual, like a proper complex number. When we have a proper complex number, something like this or something like this. Okay, we've got a real part and an imaginary part. Okay, hopefully that felt okay. Sorry for the long videos today. Just want to make sure you had enough stuff that would cover everything that you needed to know for your assignment tonight, which will be posted on Classroom. It'll be a worksheet. Feel free to copy the worksheet down, print it out, write on it, whatever you feel like you want to do, go for it. Regardless, I will see you guys tomorrow. I'll see you guys for the hangout later today, and have fun, enjoy, happy mathing. Bye, guys.